All right, so today we're going to be covering irrational numbers. So let's take a look. So first we're going to define what a rational and irrational number are. In your past classes, you should have talked about a rational number as a number that can be written as a fraction, or in other words, a ratio, hence rational. An irrational number is a number that cannot be written as a fraction. Okay, so it's a number that's not a rational number. It's a non-repeating and a non-terminating decimal. So like 0.1, 0.1011011, those would be an irrational number. Another example of an irrational number is pi. So let's take a look at our number system. So first off, we have the real number system. This is everything we've worked up with so far. We've only dealt with rational numbers. So what we're going to be learning about is irrational numbers. But first, let's talk about the different kinds of rational numbers. So let's start with the natural numbers. So the natural numbers would be numbers like 1, 2, 3, 4. It's the counting numbers, okay? They just count up. It's quite beautiful. The whole numbers, the only thing that really happens is we add the number 0 in. So it's still positive counting numbers, but now we just have 0. Integers would be the negative numbers and positive numbers. You talked about those in 7th grade math. Okay, and then rational numbers are any numbers that can be written as a fraction, such as 3/4, or 7, or -4/5, or 43/3. All of those are rational numbers. Now, irrational numbers are any number that does not fit in that system. So this would be numbers like pi. There's also another number called e. You'll talk about that when you get to secondary 3. There's some other numbers like, square root of 2. That's an irrational number because there is no number that can be written as a fraction that'll multiply by itself and give me the number 2. Also, the square root of 37 is an irrational number. If I did this is an irrational number because even though there's a pattern, there's no way to write that as a fraction. It's kind of crazy. Okay, so those are all examples of irrational and rational numbers. Now, I know that irrational numbers looks like it's in a smaller box. They're actually the same size. So there are the same number of rational numbers as there are irrational numbers. There's infinitely many of them. In fact, some would argue that there are more irrational numbers than there are rational numbers. We're not going to get into that argument. We're not in a philosophy of math class. We are in Math 8. So let's take a look at this. We're going to look at all these words and we're going to put them either in a word that describes rational or a word that describes irrational. So a ratio, I feel like that goes pretty squarely in rational. So do fractions, that's a good one. Integer, we know that goes in rational numbers. That was in the little box inside. Perfect square roots, that means we can take the square root and it ends up being a nice pretty number like square root of 4. That works out pretty great. Perfect cube roots, ooh, that's a good rational number. Equals, it feels like a rational thing. Ooh, approximate, that's an irrational thing. Imperfect, I feel like that's an irrational thing. Or the word approximate, ooh. Again, over there. Exact decimal, ooh. Exacts can always be written as a fraction. Square root of 23, I know what the square root of 16 is, and I know what the square root of 25 is, but I do not know the square root of 23, so that's irrational. The cubed root of 200, I'm going to go with irrational. Convert, if we can convert the number, it's probably going to be a rational number. Repeating decimals can be written as fractions, and pi is not one of those. So that's how that should look when it's all organized out. We have a lot of words that represent either rational or irrational numbers. Rational being more exact than not. Okay, so each of these following ones, we're going to identify if it's irrational or irrational. Rational, we're going to mark with the green highlighter, and irrational, we're going to mark with the yellow highlighter, because it sounds great to me. So 6, that's a pretty rational number. It's technically the fraction 6 over 1. If you want to think of it as a fraction, there's our ratio. It's a 6-to-1 ratio. The square root of 16, I can actually take the square root of 16. It is 4, and then it would be a 4 over 1 ratio. So again, rational. -3 is a rational number. I can write it as a fraction, -3 over 1. Beautiful. Okay, what about 6.3213351? I don't see a pattern, and it looks like it just goes on forever doing weird things, so we're going to go ahead and say that's irrational. So we have 3.16 forever. That's interesting. That can definitely be written as a fraction. That can happen. I'm not going to go look up what the fraction is because that would take me time that I don't want to take on that. So that is rational. Square root of 32. I know what the square root of 25 is. And I know what the square root of 36 is. But that's not those. See, that's 5 and that's 6. But that's not a nice pretty number. So that is an irrational number. Square root of 9, I know that is 3, which we can write as 3 over 1. So that's a nice pretty rational number. 0 is one of my favorite rational numbers because it is 0 over 1. Ta-da! Rational. Pi! We already talked about this one. It's irrational. 13.2 is technically 13 and 2/10, which you can reduce, but we've represented it as a fraction, therefore rational. All right. I want you guys to go ahead and try and mark these. On the next slide, you will find, oh, sadness. That extra decimal should not be there. Notice that. Okay. See, mistakes are fine. They just happen. All right, so I want you guys to go try this one on your own, and the next slide has the answer on it. So when you're ready, go ahead and look at that.